It says here, in a study relating to sleep and death rate, the following data were obtained. We're going to use the function y equals ax squared plus bx plus c to model the data. So what we're trying to come up with here is a quadratic function that matches up with the data that we're given for x and for y. And that works because we notice how the death rate starts up kind of high and then kind of goes down, and then it kind of comes up a little bit again as we get a little bit higher in the amount of sleep. And so it kind of will sort of follow along a parabola shape in a way. And so a quadratic function will work well in order to figure out function to match up with the data. Okay, so key thing to look at here is this is the x and this is the y values. We're going to create three equations for the three different values of x and y we have. And what we're going to do is we're going to plug those x's into this function, and we're going to plug the y in there as well. So in the first row we have a 4 for x and a 1682 for y. So that would be the first equation that I'm going to plug into, the 1682 and the 4. So the way that would look is 1682 equals a times 4 squared plus b times 4 plus c. And then in the second one we'll use our y from the second row, 626, and the x would be 7. So a times 7 squared plus b times 7 plus c. And then the third row we have 9 and 967. So 967 is y, and then we have a times 9 squared plus b times 9 plus c. Okay, so now we have all these numbers here. It's kind of crazy, but we're going to go ahead and kind of simplify things down just a little bit. This will look like 16a squared plus 4b plus c is equal to 1682. 49a plus 7b plus c is equal to 626. And then 81a plus 9b plus c is 967. Okay, we're going to use our knowledge of solving systems of linear equations in three variables to solve for a, for b, and for c. And by the way, that shouldn't be a squared, that should just be a. So this will be our three equations. I'm going to start out by taking equation 1 and equation 2, and I'm going to try to cancel out one of the two variables. So we have here equation 1, and can we see the easiest thing to cancel out here? What would be the easiest variable to cancel out? Well, c looks like a pretty good idea to try to work with since it's just a c. I just need to change 1 into a negative and leave 1 as a positive. So what I'm going to do is I'm going to take equation 1 and basically multiply it through by negative 1 and leave the second equation alone. Leave it the same. So we'll get negative 16a minus 4b minus c equals negative 1682. Okay, then I can combine that with the other equation, and we'll see how the c's will cancel out, negative and positive c. So when we add everything here together, we'll see that we will get 33a plus 3b is equal to negative 1056. And let's refer to that as equation 4. Okay, we need to do this again. This way I'm going to take equation 2 and equation 3, So if I put those together, we can do the same thing to get the c's to cancel. We'll choose one of those equations and cancel out the c by making it negative. Here I took equation number 2 and I multiplied it by negative 1 and left the other one the same. So make that a negative 49a, a negative 7b, and a negative c equals negative 626. So that seemed appropriate to combine with the other equation so that the c will cancel out. So when we combine these here, so again c will cancel out, we'll be left with 32a plus 2b is equal to 341. And let's call that equation number 5. Okay, so now we've gotten this down to just a and b. The c is no longer there. So we need to continue on with just these two equations and figure out, we need to cancel out the a or the b. The one that we choose is just merely due to what we think is the most convenient one to try to work with. I think I'm going to cancel out the b because the numbers look like they'd be easier to work with. So for the first one, I'm going to multiply by negative 2, and the other one I'm going to multiply that one by 3. So what we'll get here is negative 66a minus 6b equals 2,112. Down here we'll have 96a plus 6b is equal to 1,023. So we made one of the b's a negative 6 and the other a positive 6, so they'll cancel out. And what we'll be left with is 30a is equal to 3,135. Not the easiest number to work with, but we do need to divide out the 30 from both sides. It doesn't come out to be a whole number, but it does come out to be a fairly manageable decimal. 104.5 will be our value for a. Okay, now we're ready to continue to finish this thing up. So what I'm going to do is substitute a equals 104.5, and I'm going to substitute that into either equation 3 or 4 or equation 5. Here I'm going to use equation 5. That would look like 32 times 104.5 plus 2b equals 341. So this would be 3344 plus 2b equals 341. I need to subtract that number over. And so we're going to have 2b is equal to negative 3,003. And we'll need to divide the 2. So b is going to equal to negative 1,501.5. Okay, and we're almost done. We just need to substitute in and figure out what c is equal to. So we're going to substitute the a, and we're going to substitute the b. And I chose to substitute this in. It could go into any of the first 3 equations. I just used equation 1 to substitute in for. That would look like 16 times 104.5 plus 4 times negative 1501.5 plus c is equal to 1,682. Doing the calculation of these numbers gives us negative 4,334 plus c is equal to 1,682. So all that's left to do is to finally just add over this number and we would now know what c is equal to. C is equal to 6,016. Okay, so we've solved for A, we solved for B, we solved for C. So now we know what our quadratic function will look like. Remember, it has to be ax squared plus bx plus c. So in that case, we'd have here y is equal to 104.5 x squared minus 1,501.5 x plus 6,016. And so this function here will match up with the data that we have in our table.